let's go on to the next bearing capacity factor, or bearing capacity added factor, which is the slope or the surface slope factor. So first of all, what's the meaning of surface slope? It means you have a sloping ground, as you see. It should be continuous over here. And you decided, okay, my footing will be at this location. And here we show a footing based as inclined, but let's assume it's not. So delta just for this case is equal 0. And you have that D, that's the foundation depth. You have vertical force, you have horizontal force, and you have beta. Beta is the sloping ground. And again, Canadian uses the Vesic equation in 1973 for the sloping ground, and B is positive if the inclination is below the horizontal line. So if you have a horizontal line, the load or the soil is sloped below the horizontal line, away from the edge of the foundation. And it's valid, the solution or the coming solution is valid for beta less than pi over 4, so it's less than 45 degrees. And it's beta equal radian in the bearing capacity calculation, which is over here. So if y equals 0, the cohesion portion for the beta or for the surface slope is 1 minus 2 beta, and beta should be in radian, all over pi plus 2. If y more than 0, you have a beta, or the cohesion portion due to the sloping ground is a function of the q beta, which is the surcharge factor due to the inclined load, minus 1 minus sq beta all over nc tan phi. So now let's see what is sq beta equal. So sq beta is 1 minus 10 beta all squared. And surprisingly, sq beta is gonna equal s gamma beta, which is 1 minus 10 beta all squared again. Just 2 quick notes that you need to consider while you solve for the sloping ground using the Canadian Foundation Engineering Manual. By the way, you're gonna use, or when we will take the part that is speaking about footing on slopes or adjacent to slopes, which is apart from the H2. So for the footing on slopes, it's the same as footing with surface slope factors or with surface slope. So when I'm coming to the H2 part for the footing on a slope, I remind you that we did that before using the Canadian Foundation Engineering Manual. It's different solutions, by the way, but we will compare, okay, if we use the surface slope factors from the Canadian, and if we use the H2 method for the footing on slopes, what we will get. Now let's back to these 2 notes. Where phi equals 0, cohesion, n gamma is gonna equal minus 2 sine beta. And if phi equals 0, actually, you don't need the n gamma. Again, for sloping ground where phi equals 0, n gamma is gonna equal minus 2 sine beta. And from the figure, QS is not just gamma times foundation depth, it's gamma times foundation depth times cosine beta.